Hello, today is Tuesday, March 31st. If you're on track, this is Pre-Calculus 12.1 Matrices Notes. So, exciting, we get to learn about matrices formally. A matrix is a rectangular array of numbers. A matrix is described by the number of rows and number of columns. Now, I'm going to play here a little bit. So this is super important, okay? A matrix is defined by, and it has to go number of rows first. And the only reason why is we have to have an agreeable rule to do this. So we call those the dimensions of the matrix. So below, on the left, this is what we call a 3x2 matrix, and we write it like this. It looks kind of like a time sign, but it's not a time sign. So there's 3 rows and 2 columns, so we call it a 3x2 matrix. The second one that's on the right, there are 2 rows and 4 columns, so we call it a 2x4. And again, it looks like a little time sign, but it's 2x4. So in example 1, the first thing I want you to do for A and B is I want you to determine the dimension, and then I'm going to explain what find the element A sub 2, 3 means, okay? So first, find the dimensions of each matrix in example 1 and write it underneath. All right, in letter A, this has 3 rows and 5 columns, so we call it a 3x5. In B, there's 2 rows and 3 columns, so we call it a 2x3. All right, now let me explain what find the element A sub 2, 3. It's not A sub 23. But what this means is find the second row, third element. In the third column, I guess, let me say that, the third column. And, oops, I glossed right over that. Let me go back here. An element is each number in the matrix. So each of the numbers is called an element, and we can identify the element by the row and column that it has. So if I want to find A23, let me change colors here. So if I want to find A sub 2, 3, I'm going to go to the second row, that's the second row, and the third column. So the second row, third column in part A would be 6. So let's do that in part B. If I want to go to the second row and the third column, A sub 2, 3 is -1. Okay, so I think you're really going to like matrices. They are fairly simple. A square matrix is a matrix with equal number of rows and columns. So example 2 says create 2 different square matrices. So let me give you some examples. They are a 2x2, a 3x3, a 4x4, and so on. So you just randomly come up with one, and we use these brackets. So if I'm going to do a 2x2, I could say 1, 0, 3, 5. That's a 2x2 square matrix. That's going to be important later. I can also do a 3x3, where I say 4, -1, 7, 6, 8, 0. That's a 3x3 square matrix. All right, a matrix with only one column is called a column matrix. So if you notice this definition, and I'll try to highlight this. This is where I am. A matrix with only one column is called a column matrix. So this one has 3 rows and 1 column. It's a 3x1. You can also have a row vector, and we are going to see vectors a little later this school year, which is cool. All right, you can add and subtract matrices but they have to have the same dimensions. And all you do is add the corresponding elements. So, for example, if I'm given that matrix A is 1, 2, 3, 4, and we do read them by rows. So again, to read matrix A, that was 1, 2, 3, 4, and matrix B is -1, 5, -2, 7. So if I want to add them, these are 2 by 2 matrices. So let's make sure we're getting the hang of our dimensions, 2 by 2, and they're square matrices. So all I do is take 1 plus -1, that's 0. 2 plus 5 is 7. So I'm adding elements in the corresponding locations. 3 plus -2 is 1. 4 plus 7 is 11. All right, so if you're feeling confident, go ahead and try the subtraction, A minus B. I'll pause a moment and give you a teeny tiny head start on me. Then here we go. You just have to be careful with subtraction. I'm going to do 1 minus a -1, so that's 1 plus 1 is 2. 2 minus 5 is -3. 3 minus a -2 becomes 3 plus 2, which is 5. And 3 minus 7 is -4. Or I'm sorry, I'm looking at the wrong one. 4 minus 7 would be -3. Notice that A and B were 2 by 2 matrices, and the sum and difference are 2 by 2 matrices. All right, we can find the product of a matrix with a real number. And when you are talking about matrices, a real number with matrices is referred to as a scalar. You're going to do what's called a scalar product. So a real number is just called a scalar. And we're going to see this later this year when we do our vectors, because you can multiply the column vectors, and that's called vector multiplication. And if you take a vector times, like, say 5 or 4 or -1, that's a scalar multiplication. So, and again, this is going to be super simple. If in example 4, if I'm given matrix B, which is -1, 5, -2, 7, to do a scalar, this is 3 times B. So all you do is multiply every element times 3. So that's -3, 15, -6, 21. So scalar multiplication is super simple. All right, so we have a definition down here. 2 matrices are equal if they have the same dimensions and each corresponding element is equal. So let's continue. So look at example 5 with me. And it says if matrix A equals matrix B, find X and find Y. So what's really simple here, and again, I'm starting super simple. Do you see where X is? X is just equal to 2, and Y is equal to -4. Okay? So of course they can get more difficult. So let's look at example 6, part A. If I want to find X and the 2 matrices are equal, I don't know why the tops of my matrices got cut off. It's just an accident that those are cut off. They are supposed to have the tops to them. I think when I cut and pasted, it just cut off. So all you're going to do is set those elements equal. 2x minus 5 equals 25. And then that's just a simple equation. You get 2x is 30 and x is 15. Then you go find where y is. You set 3y plus 12 equals y plus 18. I'll give you a brief head start on me. So solving that, I got y is 3. All right. let's look at part B. Again, this is going to get I'm just taking these in small steps, going a little bit harder and a little bit harder, but still nothing challenging at this point. So on the left, this is a plus 6. 3 plus negative 8 is negative 5. So what I'm doing is this is addition. Negative 5 plus b and 18. And you actually could do that part mentally, and that would be absolutely fine if you did that mentally. So you're going to set this up as a plus 6 is 10 and negative 5 plus b is 7. Do you see I'm lining up the equivalent terms? So then a is 4 and b is 12. So that's really equivalent or equal matrices. All right, the next definition here is a matrix equation is an equation in which the unknown is a matrix. Right now we are laying a foundation for something that's coming, and we're going to just spend 2 weeks on matrices. So we're going to end up solving systems of equations. We're going to take it up to the 3x3s, where in Algebra 2 we learned how to do those by hand algebraically, and they were very, very tedious. There were so many places where you could make mistakes. We're going to find an easier way with a matrix equation. So today we're not going to get all the way there. We're going to take our time just building this nice and slowly. So again, a matrix equation is an equation in which the unknown is a matrix. Use the addition and subtraction properties of equality to solve a matrix equation. So watch what we're going to do here in example 7. It says solve for, and it's a capital X, which is standing for matrix X. So what you're going to need to do is you're going to need to subtract, still navigating here. So I'm going to subtract, and again, I don't know why the tops of my matrices got cut off. I'm going to subtract the negative 1, 0, 2, 5 from both sides. Oh, so now hopefully you can see why I had you adding and subtracting matrices. Because now if we're going to solve a matrix equation, we need to understand how to add or subtract matrices. All right, so here we go. So I'm going to take 10 minus a negative 1, which is 11. Okay, be careful, because on the left side, those are canceling. So then on the right side, I'm taking 10, 7, negative 4, 4, and I'm subtracting the matrix negative 1, 0, 2, 5. Then I have 7 minus 0, which is 7. Negative 4 minus 2 is negative 6. And 4 minus 5 is negative 1. So it says solve for x. What will be the dimensions? They have to be the same, so it's a 2 by 2. And they end up being the same because you're subtracting matrices. All right, so let's look at example 8. And again, I'm just layering this, taking it up one more level. It says solve for matrix X and what will be the dimensions of X, and how do you know? So this is going to be interesting here. This is going to be 2 steps. So I'm going to first subtract matrix 7, 0, negative 1, 2, negative 3, 4 from both sides. So on the left side, that's going to cancel. And if I'm going too quickly for you, please feel free to pause the video to kind of get written down what I've written. Also, I'm trying to really keep things to 30 minutes as we begin and try to navigate distance learning together. You might need to watch a video twice. Maybe not on these beginning few because they're fairly straightforward, but as the material might get a little more challenging, I'm trying to build in time where your day is, you're just going to watch that video and maybe watch it twice. So if you notice that some of the videos are not 30 minutes, that's okay. It's just for those of you that really need to see it a second time. All right, I'm going to move this over and change color so you can see what my new thing is. So I now have negative 3x equals, I got to be able to see this. Okay, so now I'm going to take 10 minus 7. So that's going to leave me with 3. 0 minus 0 is 0. And then I did 8 minus negative 1, which is 9. Then I have negative 19 minus 2 is negative 21. Negative 18 minus negative 3 is negative 15. Then 10 minus 4 is 6. All right, then what do you think we're going to do if I have negative 3x equals that? All right, well, hopefully you said divide everything by negative 3. So that's going to leave me with negative 1, 0, negative 3, 7, 5, negative 2. So the dimensions are 2 by 3, because when you're adding and subtracting, and if you multiply or divide by a scalar, it's going to keep the dimensions, okay? So here are the properties of matrix addition. They are actually the same as the properties of equality. So number 1 here is a plus b equals b plus a. The commutative property for addition holds. That's not true for subtraction, but it's true for addition. So matrix A plus matrix B equals matrix B plus matrix A. The associative property, I can group the first 2 matrices together. And then, or I can take the first one and add the second 2 matrices together. Then I have the additive identity, a plus 0 equals 0 plus a. And then the additive inverse, a plus negative a equals negative a plus a, which is equal to 0. All right, so that concludes our first